welcome to VTeach. Now we will discuss about wrapper classes, what is the purpose of wrapper class, and two more topics, that is auto boxing, auto unboxing, and what are the predefined classes present in java.util package and some of the predefined classes. First of all, let's discuss what is a wrapper class. A wrapper class in Java provides a mechanism to convert primitive into object and object into primitive. What do you mean by converting object into primitive and primitive into object is there are predefined data types for us in Java. There are 8 types of data types present in Java, which are categorized into 4 types. They are Boolean data type, numeric type, character type, and Boolean type. So these are divided based on the categories. Now the thing is, wrapper classes, why these wrapper classes are used is they are used to convert a primitive data type into objects and objects into primitive data types. So doing this can be done by using wrapper classes. There are some predefined methods present in the wrapper classes to perform this conversion, converting primitive into object and object into primitive. So doing this is known as auto boxing and auto unboxing. What is auto boxing and auto unboxing? Convert primitive into objects and objects into primitives automatically. The automatic conversion of primitive into an object is known as auto boxing. If I convert a data type into an object, it is known as auto boxing. If I convert an object into primitive data type, it is known as unboxing. So auto boxing and auto unboxing are two different things. Auto boxing is the process of converting a primitive data type into an object, whereas auto unboxing is a process of converting an object into primitive data type. Now all the wrapper classes are predefined classes. So these wrapper classes are present for the 8 data types we have. So where these wrapper classes are present is they are present in a package. What is a package? Package is a collection of predefined classes. In java.lang package, all these wrapper classes are present. So wrapper classes are there for data types. For data types, 8 data types, there are 8 wrapper classes. So these 8 wrapper classes are present in java.lang package. So let's see what are the data types that are relevant for data types. First one is primitive data type is Boolean. The relevant wrapper class is Boolean. Data type char, wrapper class character. Byte, primitive data type, byte wrapper class. Short is the wrapper class. Int is the primitive data type. Integer is the wrapper class. Long. Float, double, and double is the wrapper class. So by using wrapper classes, what we can do is we can do either auto boxing or auto unboxing according to the user requirements. What is auto boxing and auto unboxing? The automatic conversion of primitive data type into its corresponding wrapper class is known as auto boxing. We have a primitive data type, I am asking it to convert into its relevant wrapper class, then it is known as auto boxing. For example, byte to byte, char to character, int to integer, long to long, float to float, boolean to boolean, and double to double, and short to short. If this is done, then we call it as auto boxing. Here in this case, what we are doing is we are converting data type into object, means wrapper classes. That's why it is known as auto boxing. So here we have written a small program for this wrapper classes for auto boxing. Wrapper class example 1. In this we have written public static void main, and then we have written int a is equal to 20, and then int I is equal to integer or value of a. So what we are doing is we are creating an object for integer class. We are creating an object for integer class. Then what happens is this value of a, which is present in the numeric data type, is converted into wrapper class and it is stored into the variable, that is object I. Next what we are doing is we are assigning the value of a to reference variable j. Now what happens is the compiler will automatically write a value. From a, it is going to convert it into I. Now if I print the value of I and j will be converted into ing are converted into wrapper classes, but a is a normal primitive data type. So here what happens is a is 20, which is prints in a normal way, that is as a numeric value, whereas I and j were wrapper class values which will printed in the format of wrapper class values. Now automatic convert. Now coming to unboxing. What is unboxing means? The automatic conversion of wrapper type into its corresponding primitive type is known as unboxing. If I convert a wrapper class type into its corresponding data type, then we call it as unboxing. It is the reverse process of autoboxing. Based on the instruction that we are written, either autoboxing or auto unboxing will be done automatically by using wrapper classes. So let's see one more example for this by converting it into reverse case from wrapper class into corresponding primitive types. Wrapper class example 2, and then public static void main. I have declared here an integer object a. Integer a is equal to new integer of 3. So we are creating a wrapper class of type integer, object of type integer, and then int a is equal to a dot int value. Int value is the predefined method present in integer class which is used to convert a wrapper class type of integer into normal data type. So here we can see converting integer into int explicitly. Now what happens is j is equal to a. So j equal to a, what it is going to do is unboxing. Now compiler will write int value internally. Since we have written directly, it automatically converts. If you write it, it will be converted. If you don't write it, automatic compiler is also going to do that. So the values of a, I and j are printed. A is in the format of wrapper type, whereas I and j are in the format of normal primitive data types. So concluding, wrapper class is by using wrapper classes we can do either auto boxing or auto unboxing. Auto boxing is the process of converting a primitive data type into wrapper class type, where we declare normal variables of type integer, character, float and double, and then we use objects of primitive wrapper classes and then we convert them. If I write an instruction to convert it, it converts, or otherwise it is done automatically by the compiler during its execution. Auto unboxing is a process of converting a wrapper class type object into primitive data type. For this purpose, we have different methods for different classes. For integer type, we have int value. For float type, we have float value. Boolean, boolean type. Char, character type. String, string type. Float, float type. Double, double type. We all have these type. Byte, byte type. Short, short type. Long, long type. So these are all the predefined methods that are present to convert these purposes. Next one is java.util package classes and its interfaces. So we already seen what are the predefined packages in the previous topic. What is a predefined package? Predefined package is a collection of classes that are already defined and they are present in the packages. It's already defined and it is present with the JVM. So what we need to do is we need to just use them in our programs by using the keyword import space package name. Now let's discuss about a main class, main package, that is java.util package. So the java.util package is the default package that will present with each and every program that you write. Even if you don't write import statement, JVM is going to write on behalf of you and it is going to place it as the first instruction in your program. Even you don't import it, it will be imported into your program indirectly. Now let's see some of the important methods that are present in this java.util package. First one is arrays. This class contains various methods for manipulating arrays. So what do you mean this manipulating arrays means? We have a predefined class known as array which is going to allow for dynamic allocation of memory for us, whereas dynamically we can change the size of the array or we can reduce the size of the array or increase the size of the array. To work with these type of operations we have a class known as arrays. So the manipulation that we can do is searching and sorting. So in the arrays topic we have discussed that searching and sorting can be done by using some of the predefined methods present in arrays class. This is that arrays class. Next, calendar. This calendar is an abstract class that provides methods for converting between a specific instant in time and set of calendar fields such as year, month, day and month of a year. So there are different, it's a predefined class and it is an abstract class of all the classes relevant to the calendar. What it contains is it contains some methods which are used for converting a specific instant in time into calendar fields. So we can work on calendar fields like year, month, day of a particular month or a particular hour. So these are some of the constant values that are present in this calendar where we can work on them. Next, collections. So this collections is a predefined class. This class contains exclusively some static methods that operate or return collections. Means if I want to work with a collection of values like list, array, as well as set, link or list, all these classes or subclass of this collection class where we can store multiple values at the same time. So in order to work with these collections, we have a predefined class known as collection. Next one, date. The class date represents a specific instant in time with milliseconds precision. When I try to print the object of a date class, it's going to print what is the date of what is the current date with hours, minutes, seconds, with milliseconds and precision also. Next, objects. This class consists of static utility methods for operating on objects. If I want to work on any objects, there are some predefined methods. That methods are present in this objects class. Next, random. To work with pseudo-random numbers, whether it is of type integer or float or double or any type, we can work with pseudo-random numbers with using the methods present in this random class. Random is a predefined class present in java.util package which is used to work on random values. For example, if I want to allot roll numbers to the students randomly but not in a sequential way, I cannot pick number every time. I might forget what is the next number I need to choose. In that cases, I can use this random method which is going to give a unique number every time based on the value that you have supplied from 0 to 1 or 0 to the number supplied. We will see about the random class in the next coming topic also. Next, scanner class. Scanner class is the most important class present in java.util package which is used to take input from the user. If I want to take input from the user using the keyboard, we can use scanner class. So it contains different methods like next int, next float, next double, next char, next line, next. So these methods are used to work with different data types. By using these methods, we can take any type of data from the user. Next, stack. So the stack is going to perform last in first row type of operations on objects. String tokenizer. What the string tokenizer is, it is going to divide a string into tokens. Means for example, if I had written a string as welcome to Java programming, it's a collection of strings. So if I use string tokenizer class, what it is going to do is if I pass this string to the string tokenizer, it is going to divide that welcome to Java programming string into different parts known as tokens. Welcome will be one string, 2 will be one string, Java will be one string, and programming will be another string. What we can do is we can divide a string into tokens by using string tokenizer class. Next one is vector class. What this vector class is used to do is vector class is used to work on dynamic arrays. Means it is also similar to arrays, which is a collection of elements of same data type. But what is the difference between a vector and an array is it can grow its size. So this vector class implements a growable array of objects. We can create array of objects of same type by increasing the vector size or reducing the vector size. So these are some of the classes present in java.util package. Now let's see what are the interfaces present in this java.util package. The first one is collection interface, which is the topmost interface of all the sub interfaces of related to collections. So that's why we call this as a root interface in the collection hierarchy. There are different types of interfaces like a list collector, set, and other things. So for all these things, the root interface is collection. Next, comparator. So what is the purpose of this comparator is, for example, I want to arrange the elements in an order, either in ascending order or descending order. I will define a comparator which is used to arrange the elements either in an ascending order or descending order. So what it contains is it has a comparator for comparison function. What it does is which imposes a total ordering on collection of objects. So it's a collection of objects. On collection of objects only we can apply this comparator interface. It has a comparison function which is used to compare the successive elements and then arrange them either in ascending order or descending order. We can write a comparison function there. Next, dequeue. So dequeue is used to work with insertion and removal at both the ends. Dequeue, it has both ends. One is a rear end and another one is front end. We can do insertion and removal at both the ends. Next, enumeration. This enumeration is an interface which is used to create a series of elements one at a time. Means it is going to give a number of elements. Whenever we call it at a time, we are going to get one element at a time. It has some methods like has more elements and which is used to check what is the whether there are any elements or not. If there is an element, we can call the next element method to retrieve the next element. Next, event listener. This event listener is an interface which is the interface of all the events that are generated by the AWT components. Let us suppose that the examples are mouse event, keyboard event, text event, action event. All these are the events. For all these events, there will be event listeners. What they have to do is they have to listen to the events that are generated. Next, iterator. An iterator is used to repeat on the collection. Means if a collection, it is a collection of values. As we are saying, it is a collection of values. If I want to refer each and every value in the collection, I can use an iterator interface to refer to each and every value present in the collection. Next, list. List is an ordered collection of values. Here the elements in the list will be an order. This list is a sub interface of collection. List iterator. This list iterator is used to iterate among the values present in the list. Next, queue. Queue is used for holding elements prior to processing. Means queue will be temporarily used to store the elements when we want to perform an operation. Next, set. A collection that contains no duplicate elements. If I want to create an array of values where it should not allow duplicate values, I will use an interface known as set interface. Whereas for other data structures like vector, list and other things, duplicate elements are allowed, but in set we don't have duplicate elements. It allows non-duplicate elements only. Even if you try to initialize, but when it is stored internally in the memory, only a single copy of it will be stored. Duplicate values will not be stored. Thank you.